Hello and welcome to TidyX episode 148. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. Thanks for checking in with us at TidyX. We appreciate having you here. Today, we're going to be continuing on with, we've done a bunch of work on Shiny apps. And today, we're going to continue on talking about statistical model building in Shiny apps, basically giving your user the ability to input their data, select an outcome variable, select an input variable, and get a model output. So a no-code solution to model outputs, and we have some different ways of that we're going to try and extend this in the coming weeks into other
Yep.
things. That
Leave a
said,
comment down below if you have an idea of something that you'd like us to do for the
yeah,
show.
if you have something that you'd like us to add, comment down below on the YouTube channel. We do have a Patreon page. We're always thankful for whatever you'd like to donate. That said, we're going to jump in today's episode on statistical model building in Shiny for your users. So Ellis, what do we got? We got the end product up so we can show that before we
Yep.
build it. What do we got?
All right, let's go. All right, so we've got this left-hand side here that's got some user interface capabilities here. We've got this select a CSV, select a continuous outcome variable, and predictor variables. Of course, in these two, there is no content to select because there's been nothing uploaded at this point. So we're going to go and select a CSV file. Specifically, we are calling for a CSV file. I'm going to go over into our model building stuff here so we can, let's upload empty cars, that classic data set that we all know, and boom, pops up with some statistical results for us almost immediately. Gotta love that. So it looks like over here we've got like a model summary. We've got a bar plot, a histogram of mean absolute error.
The
Uh,
residuals, yeah.
Excuse me, the residuals. Um, the predicted versus actual values, which at this point, because it doesn't have any predictor variables, it's selecting a y-intercept. So they're all going to have the same predicted value. And then down here, we've got a data, a DT that looks like of all our wonderful content there.
Mm-hmm.
So now that we've uploaded data, we can see the outcome variable dropdown has a bunch of content that we can select. We're just going to leave that as MPG at this point. Now we go over to predictor variables, and it's also got a bunch of dropdowns here, and you can select this time as many predictors as you'd like. Be careful not to select the same as the outcome variable. Of course, then you'll have a perfect prediction because one is one, right? And so that's kind of a quick introduction. Like, this is intended to give you, here's some skills that you could use to do a statistical modeling Shiny app. Of course, we will expand on it in coming weeks. So make sure to subscribe so you can see the next steps that we do if you're not already subscribed. So that's
Yeah.
kind of a quick introduction to how it works. Let's jump into the code here. So let's close that down. Patrick, you want to start us off?
Yeah, so we're using three simple packages, Tidy versus Shiny and DT, ones that we use every week. We're just going to set the theme set to classic for, for our plotting purposes, make it look nice. I commented out the creation of the data sets here because we don't need them. I just created them to save them so that we had, something to upload to the Shiny app. So then once we're in it, we're ready to kind of rock here. The UI generally, as all of our UIs, is pretty simple. So it's a fluid page. Our title is going to be model builder, and we've got a sidebar panel which has three inputs. The first input being, hey, we want to select a file. We're going to make it a CSV file. Obviously, you could change this and make it whatever you want. You could give it options, but that's what we're doing here. Yeah, accept will allow it to take other options, but we're just going with CSV here. The select input variable options are for the variables. So we have a Y variable and we have X variables. And there's a little trick here in that if we don't have a file uploaded, we have nothing to display. So our choices are blank. And we're going to take care of that in our server because we're going to use a session argument to say, hey, once a file is uploaded, go ahead and populate those options. And so right now they're blank. All we do is we give them an input ID and we provide a label that the user sees. Obviously for the input variable, for the Y variable, that's a single variable, so we don't allow multiple. But for the X variable, X variables, the independent variables, we're allowing multiple selections there, so we set that to true. Finally, our main panel, as we saw, the first one is we want to just print the linear model output summary. So we use verbatim text output to just get that printed smashed right on the screen. I set a few breaks just to give some breathing room between the next group of plots. And there I'm just setting a fluid row, which I split the 12 units across in half. The first plot is going to be a residual plot, a histogram of the residuals. And the second plot, as we saw, is our predicted values and our actual values, and a line of equality across the middle, an intercept of 1 and a slope of, or an intercept of 0 and a slope of 1. And then finally, as a sanity check for the end user, I'm just going to output whatever it is that they uploaded as a DT table, so they can check all their data, make sure it's there, make sure nothing looks weird, etc. So that's the UI. It's pretty easy to kind of plink through.
Yeah, and keep in mind these values here are the IDs that we are going to be referencing later on in the server. So
Yeah,
we didn't for everything write out this is the input ID or the output ID. We just typed in the ID because we're not making
that's
any
it.
manipulations in the UI to the output, and there's no additional features that we need to select coming in. So I think plot output doesn't really have any additional features here. I guess it's got width height.
Well,
Okay,
you could
there
set
are
width
a
and
few
height.
things.
Yeah. Yeah.
Ignore what I said there. But we're not doing any of those things right now. We're only looking at the ID. We're only setting
Yeah.
the ID here and using default
Yeah.
values for the rest of it.
Yeah. So we want to run that UI. You also probably
Oh,
want to get you have a little search up at the top open. So you
oh
probably
yeah.
want to close that so that they could see the top of our, uh,
I mean, I guess.
top of our screen. There we go. Now we're into the server. Ellis, you want to take us through a part of this?
Can do. So as usual, our server is a function. So it has three inputs: input, output, and session. Historically, we have not used that session input to that function, but this time we will. It has a purpose this time. But of course, is the way that we like to set up our server functions is the way that we like to think about in the order things are going to happen, even though technically we don't need to do that. So the first thing that needs to happen in our Shiny app is the uploading of the data set. Once somebody has clicked on that file input, they are going to be presented with a file browser. They can then select the data they want to upload, and that is going to update the input $file input in our Shiny app. So we're going to have this reactive and it's going to be observing essentially input $file. If that value is null, which means they've not uploaded anything or they've removed the data set from being uploaded, we want input dataset to be null. That way, all our downstream stuff can be just checking, hey, is input dataset null?
Mm-hmm.
If it is null, hey, don't do anything. Don't worry about it. But as soon as they actually have uploaded a dataset, it's going to update input $file, and it's actually going to update this sub entry data path. And so that is actually a representation of the uploaded file into the basically the temp file that the Shiny session can actually see. Um, since in theory the Shiny app is not running on your computer, it doesn't actually see the content on your computer. It is
Mm-hmm.
somewhere in the ether that it was uploaded. And then because we're requiring everything to be a CSV, we're able to use the read.csv function to read that file in and assign the output to input underscore dataset. Now we've got our data loaded into our Shiny app. We can go do some more interesting things because that kind of drives right the rest of our Shiny app. And here is where we are going to be using session. So we're going to observe again that a file has been uploaded, because once a file has been uploaded, that means we can do something with it and update our inputs. And so we're going to use the function update select input to update the yvar and the xvar potential selection opportunities here. So the first argument in update select input is the session. And so that is the session that we're in. So don't worry about what exactly that object is. Just know you need to do that. As you get into more advanced Shiny stuff, that's when this understanding how the session object works becomes more important. Here, we're not worrying about that. We have the input ID that we're going to be updating. So we're going to be updating yvar. We can choose to update the label. So in this case, it's identical to what was there before. We don't have to select that if we don't want to, but don't worry about it. And then finally, we're going to select the choices. We're going to pass on, hey, here's the things that you can actually select. And here we're blindly updating, hey, let's just throw in all the column names from input data set. And the same sort of idea is applying to the xvars. The difference is because yvar is not multiple is false by default, that means it's going to automatically select the first entry of choices as the default selected entry. Xvars, because it's multiple, will not, it'll remain blank. And so kind of understanding how multiple things, the options that you set up here impact this update is important. All right, so now we've got that. So we can select our predicted or outcome variable and our predictor variables. We can do a model fit. And so the way we set this up, it's just reactive. Again, we've got this rec here, which will prevent this reactive from firing anything below if input data set is not truthy. And there's a couple of different ways that it can be not truthy. One of them is being null. So if input data set is null, not going to do anything, not going to try to do a model fit, which makes sense. Then we take our input data set. Remember, it's a reactive, so we have to use the parentheses there to actually get the value out of it. And we're going to rename the input yvar, which remember is only one variable, into dependent var. And then we're going to select the rest of the input xvars. We're going to assign that to dat, and that way dat is a subset of the data set that only has the variables we care about. And because we've renamed the yvar that we're trying to predict into dependent var, this makes this section really simple. And we're just running an LM, so we're running a linear model, the dependent var tilde dot. And that's what tells fit or LM to run dependent var predictive based on all the rest of the data in dat. And so that's why we're able to have this very simple formula. We assign it to fit and we just return fit. Technically, we don't need to do that, but it makes it a little bit easier for us, and we're assigning that to the reactive fit. Okay, so that's kind of all the setup. That's the model that we've now built and we're run, but we want to get some outputs out of it. Patrick, do you want to take us through some of this?
Yeah, so we had a few outputs we were going to show to the user. The first is from that verbatim text output. We're going to render print, and we're actually just going to take the summary of that linear fit model, and we're going to plink it right there. We're going to throw it up on the screen. As always, with all of these outputs, we're using the rec input data set so that if there is nothing, you see nothing. The other next one is we're going to set this residual plot. So it's going to be render plot. I just go ahead here at the top and calculate the mean absolute. I don't know why I have a P there. It should be MAE, but it's not a percent error. But anyway, it's the mean absolute error. And with the residuals from the model fit. So the mean absolute residual of the residuals. And I just store that as a little string there because I want to use that as the title of my plot. And I'm going to just use a base R histogram. In the X label, actually, we could put residuals as the X label title. We didn't have that there, so it was a bit confusing. So it's basically just a histogram of those residuals. The main or the title is going to be mean absolute error equals mean absolute error value. The X label is the residuals, and I'm setting it up in AB line that is vertical at 0, meaning that it would be completely 100% perfect predictions. The color is going to be red, the line width is going to be 3, and the line type is 2, which indicates that it will be dashed. The next plot, what's that?
I was like, oh, you're doing a vertical line. Well, never mind.
Yeah. The next plot is our predictions. So again, we require the data set. We're taking the input data set. It is reactive, so we use the parentheses. We're going to do the same selection here. So for ease of use, we're going to name the yvar as our dependent variable, and then input var as everything else. Then we are going to do the mutate, and we're going to make some predictions with our model. Remember, the model itself, the fit itself, is reactive also. So we use the parentheses at the end of that. The new data is the data set that we're piping in here, which is the data that we're selecting from our input data set. Now we're making a simple ggplot here. So the x-axis is going to be our predictions. The y-axis is going to be our dependent variable. We're going to make it a point. It's shape 21. That means it's going to be blank filled unless we give it a color. We're going to fill it with pale green and color it around the circle with black. Alpha 0.4 is just going to make it a little bit of a opaque clearness, sorry. And the size is 3.5. So it's a little bigger. The geom AB line here that we're setting is going to have an intercept of 0 and a slope of 1. So it's just going to be a 45-degree cut across the page. We're going to make that a size 2. Color is going to be red. Line type is dash. And then we're going to give this some descriptive labels. So on the x-axis, again, we have our predictive variables. On the y-axis, we have the actual observations. And the title is the actual values versus the predicted values. And then finally, as the sanity check for the user so that they can look through their data, make sure it all came in properly, investigate it if some of the models look weird, and search for things. We are going to just take that input data set and we're going to plink it out as a data table from the DT package so that they can check it out. And that is the entire server. And when we run this, we get a cool Shiny app that can make some models for you. So
Again, let's upload. This time, let's use the MLB batting data set here. So, of course, we've got some errors coming out here because the data set has been uploaded. So, input data set is no longer null. So, these will try to be triggered. But player ID is not a numeric or continuous variable. So, let's update that to H, which is hits. Boom. We get results out of this. And then down here is the raw data set, of course, that you can look at here. Of course, it's rather wide. Lots of data going on there.
Yep.
Let's select some predictive variables. So let's go SO, SB, HR. I don't know.
League ID, whether they're in the. Oh, there you go. Wow. So you
Yeah,
so you selected team. That's a lot.
Yeah, because that's
and
a
it is
not
pretty easy.
continuous
You could
variable.
and that's cool. You could select, and if you select league ID, it'll give you the categorical variables, just categorical variable LG.
LG ID.
So there it is.
Yeah.
So the National League is so the American League is wrapped up in the intercept, and the National League is the level that's being displayed for the beta coefficient there of -3. We get our mean absolute error of about 15 what is it, hits. Okay, and we see that those are residuals on the x-axis, and we have our nice predicted plot, and we have just a cool output. You can use your imagination. You could build other outputs. This is just a way to kind of get you started with building end user model end user model building Shiny apps, and basically
kind of give the power again to your stakeholders. This is going to multiply your effect such that you don't always have to be the one that's running this. You don't have to come up with the anytime somebody goes, hey, I wonder if this random variable is predictive of some other thing that they decided that they care about that day, rather than having to go to you and go, hey, data scientist, I need you to make a model for me predicting this on this. They can self-serve. Of course, you'll have to maybe do some education on like, hey, what do p-values mean? What does a predictive value mean? When they selected league ID, the fact that they're only seeing one means that it's like there's some education involved with that, but that'll then impact or multiply your impact substantially. And so it's all about weighing impact and education of your users of your Shiny app. So maybe put a little explainer, down below in case they forget.
Yeah.
So with that is episode 148 of TidyX. As always, my name is Ellis Hughes, and you can find me on various social media sites at Ellis_Hughes.
And my name is Patrick Ward. You can find me on Twitter at OSP Patrick. You can find the screencast on Twitter at tidy_explained. Feel free to tweet at us, share us. We always love that. Easiest way to hit us up, YouTube channel, like and subscribe, drop questions, comments down below. If there's other extensions of this concept of model building within Shiny that you'd like to see, hit us up. And as always, we do have a Patreon page. We love doing the show. If you feel like it's positively impacted you in some way and you'd like to donate back to us, we're always appreciative of anything that you'd like to give.
Thank you all. so much and keep on exploring your world.